All right. Let's look at yet another question. So you have this one here. The first thing you want to do is you check. Can I separate x and the x term to the right side as well as y and the y to the left hand side? Most likely not. Most likely not. All right. So let's try using y. So y it's equal to v of x, such that we also said that the y dx from our previous class, the y dx gives you v plus x dv dx. All right. So this is what we said in our first class on this particular topic. All right. Link in video description. Let's solve this, please. How do you solve this? Of course, substituting. What do you do there? We said this one here, the y dx becomes this. So v plus x dv dx is equal to, wherever I see y, I'll put vx. It becomes x minus y is vx all over x plus y is vx. You have this. All right. I've said whenever you're at this point here, you want to look forward to the fact that you can factorize your x term and cancel out. Okay, so I have v plus x dv dx is equal to, factorize x from here, so I have x divided by x gives you 1 plus vx divided by x. So if I cancel x here, I'm left with what there? Sorry, minus. Please, minus, please. Minus vx divided by x. X cancels x, I'm left with what there? V. So you have this. This all over. Let's come to this one here. You can see your x. You can see another x term here. If I factorize x from here, what do I have? X divided by x here gives you 1. So I have 1 plus, of course, vx divided by x. X cancels x, I'm left with v. That gives you what there? V. You have this. From this point here, this will cancel this, and it is off. What are we left with? We're left with the fact that v plus x dv dx it's equal to 1 minus v all over 1 plus v. In solving this, the task is simple. Move v over here. I'm left with x dv dx. It's equal to, this becomes 1 minus v all over 1 plus v. V comes and becomes what there? Minus v. So you have x dv dx, it's equal to, of course, this is all over 1. If I take LCM, the LCM here is what there? 1 plus v. So 1 plus v. LCM of 1 plus v and 1 is 1 plus v. 1 plus v divided by 1 plus v. It gives you 1. 1 times numerator here. 1 times 1 minus v gives you what there? 1 minus v. I'm done. Minus, so minus into 1 plus v divided by 1. Of course, anything divided by 1 gives you what there? That thing. So 1 plus v divided by 1 gives you what there? 1 plus v. Use 1 plus v to multiply this. Becomes minus v into 1 plus v. All right, just the same normal fraction solution, please. All right, work on this. What do you have here? X dv dx, it's equal to, expanding, I have 1 minus v. Minus v times 1 gives you minus v. Minus times plus minus v times v, v squared, all over 1 plus v. Now, proceeding from here, what do we have here? This will give you x dv dx, it's equal to 1 minus v minus v gives you what there? Minus 2v minus, what do you have here? V squared. So you have this. What do you have here now? 1 plus v. What is here? What is here? What is here? Look at it. What is it? That's why I said this thing can be very, show you what complicated. We have to open your mathematical eyes. What is it here? This thing looks familiar. If I factorize, what do I have? Difference of 2 squared. A squared minus b squared is equal to a squared minus 2ab plus b squared. Look at this thing carefully. Look at this. Is there we can work on this? So to factorize is what you have. For time's sake. You said? Now hold on. By the way, this is equal to, this one here is equal to a minus b into a plus b. Let's see for this one here. If you take 1 plus v to multiply 1 minus v, do we have this? 1 times 1, 1. 1 times minus v, plus, and no, it doesn't work. They have minus, it doesn't work. So this is not difference of 2 squared. Nope, it does not work. Oh, don't worry, I see it now. Don't worry, I see it now. Don't worry, I see it now. I see it now. Don't worry, I've seen it now. I've seen what I should see now. All right. Yeah. I've seen it now. So look up. So the thing about this is that there's no express way of solving this. It will always change. So you just have to open your mathematical eyes. How do you solve this? What do you see? Do you see what I see? You don't see it. Let me show what I've seen. Do you know that? Yes, now. You know if I differentiate this, I'll have this. Yeah? You don't see it. Okay, don't worry. So let me do this. Look up. Okay, let me do step by step so that I can follow up. So here's the first thing I want to do. In solving this, here's the first thing I want to do. We know how to solve this already. I've said in solving a case like this, where you have x dx from the part 1 on a previous class, I said the x goes to numerator. This man comes to what there? Denominator. But don't worry, let's just use the layman's, collect like terms and everything. That stuff is boring, but no problems. For teaching sake, let's take this here. I have x, let me do it for step by step. X dv all over the x is equal to 1 minus 2v minus v squared all over 1 plus v. So look up, please. Let's multiply this and this, this and this. So I have this 1 plus v into x dv is equal to this, and this becomes 1 minus 2v minus v squared into the x. But wait a minute though. Why is not nobody solving it? I thought you guys said you want to solve on your own. What happened? You can't check here, Abby. Okay. So in solving this, of course, simple task, divide here by this 1 minus 2v minus v squared. Divide here by 1 minus 2v minus v squared. There is something about note arrangement. Right? Well, anyway, this is a video, so you get it better. If you're arranging your notes from this point, don't really do this. It might not be logical. From this point, the next thing you want to write is that collecting like terms or cross multiply. Please, cross multiply, you now have this one here. They now say divide by. If you do it this way, it will look a bit confusing, right? If you keep this now, after like 2 days, from here to here, might look confusing, might for some persons. So what you want to do is that you want to say collect like terms first. At this point, now say divide both sides by what you have here. Then you proceed. So from there, you have this and this. So this cancels man off. I'm having here as, here is 1 plus v, this multiplying x, then the v. To save our time, right? Let me bring x outside. To save our time, let me bring x outside, and that will be x times this times the v. Let me place this one to the v, since they both have v. This and this are the same thing. All over. Also, I'll leave it with this man here. 1 minus 2v minus v squared. This is equal to, there's nothing here. I'm left with the x here. The x. I want to bring x here. What do I do? The simple concept here can say divide both sides by x, such that you now have divide this by x, divide this by x. This will cancel this. Mathematically is correct. But then again, I think I told you already in our first example that if you have this case, it will transform to give you the x over x. I've said that before. But you can say divide both sides by x. This thing looks weird, but it's correct. If you're not okay with this, you can say multiply both sides by what there? 1 over x. So at this point, you can now say multiply this by what there? 1 over x. Multiply here by what there? 1 over x. You see, arrive at this. So I'm saying, let's say you're at this point now. At this point here, and you don't want to do this thing here. You don't want to do this. You're just here. You don't want to do this. You can now say at this point, you can say multiply here by 1 over x. Multiply here by 1 over x. This will now cancel this. This one looks much more usual. So you now have that 1 plus v all over 1 minus 2v minus v squared. This dv is equal to, this is dx, or 1 over x, 1 over x dx. At this point, you can now say integrating. Which method are we using here? Substitution. Why? Integration, I have that the integral of 1 plus v all over 1 minus 2v minus v squared. This dv is equal to the integral of 1 over x dx. Well, how do we solve this integration? How do we solve it? Is that which method are we using here for this one here? This one will give us ln x plus c. Don't stress. Which method do we use here? Partial fraction. Why? Partial fraction. Why? Substitution. Why? By part. But I'm having 1 now plus v. So you have to shine your eyes. Yes, shine your eyes. See this thing here. If I factor, those of you saying partial fraction, please listen. You only use partial fraction under 2 conditions, although 1 though. You only use partial fraction when the degree of the numerator and the degree of denominator are the same. So if I'd had 1 plus v and then 1 minus v, I would have used partial fraction. If I have 1 plus v, this all over 1 minus v, here I would use partial fraction. You only use partial fraction under 2 conditions. Condition 1, when the degree of the variable in the numerator is equal to the degree of the variable for the denominator, or should I say when the highest degree? When the highest degree of the variable of the numerator is equal to the degree of the highest variable of the denominator. This is condition 1. Condition 2 is if the degree of the numerator is higher. That's why I use partial fraction. Partial fraction is used when the degree of the numerator, the highest degree of the variable of the numerator, is the same thing as that of the denominator or is greater. In this case here, the highest degree of the variable is 1 here. The highest of this is 2, so it cannot be partial fraction. Please get this and know it right. It cannot be partial fraction. Now, in solving this, my task will now be, if I differentiate this, do I get this? If you look at it ordinarily, you might not get the answer. You might say no, but yes, you can actually. Because look at this. So, I'll solve this outside and bring it here. All right, let me solve this outside and bring it here. Now look at this, please. Let me solve this man, please. Just make sure that we don't go in circle because this will be a bit lengthy. So let me just bring it here, solve it, then bring the answer here. Now, in solving this, please watch this, please. Watch this. I have, let me use 2 here. So from here, what you should have next is this. The integral of 1 plus v all over 1 minus 2v minus v squared dot dv. How do you solve this? We use substitution. So look at this. Let u be equal to denominator 1 minus 2v minus v squared. Differentiate this with respect to this. We'll have that dv, du dv, please. U with respect to v, du dv is equal to 1 gives you constant, and that's 0. Differentiate constant, you have 0. So it's off. Differentiate minus 2v. Of course, that gives you what there? Minus 2. Right? Just imagine v was x. If I differentiate minus 2x, I'll have minus 2. So the same way, I'll have this. Minus, differentiate v squared. What do you get there? 2v, obviously. Right? Multiply by the power subtract. So I'll have this. From here, if I factorize, I'll have that du over dv is equal to, I can see minus 2 and minus 2. If I take out minus 2 here, minus 2 divided by minus 2, you have plus 1. Here again, if I have minus 2v divided by minus 2, minus cancels minus, becomes a positive answer. 2 cancels 2, I'm left with v. So I have plus v. So plus v. Minus 2 times 1, minus 2. Minus plus minus 2 times v, 2v. I have this. All right, at this point here, let's get the value of dv. To get dv, don't stress yourself. Move this man downwards, move this man upwards. That's the concept there. So I have du all over this one here, minus 2 into 1 plus v is equal, this is v, please. 1 plus v is equal to dv. Right? At this point, you should know that you don't leave a denominator as a negative. So what do? Take this man and push it up here. So you have this. If I put this man back into this equation, if I put this man here, this one, back into this equation, this becomes so from here, substituting the integral of 1 plus v all over, we call this u, that's this, all over u dot, what's dv? Look at it here. dv gives you minus du all over 2 into 1 plus v. You can see this. So this cancels this. So it's off. It's off. Right? And this is equal to the integral of, what I have here is 1 all over u dot, to save time, this is minus 1 over 2, minus 1 over 2 dot, what you have here is du. So du. Okay? Right? 1 over, this is 1 over u, first in there, dot, minus 1 over 2, separate it, and then the u. Of course, when integrating, the constant term comes outside integral sign, and that's equal to minus 1 over 2 integral of 1 over u dot du. This man has been sent out. This will give you minus 1 over 2 integral of 1 over u gives you what there? Lin U. So you have lin U. You can add plus C, but that's not the case. We're working with dv now, don't forget. So, but what U is equal to 1 minus 2v minus v squared. That means my answer is equal to minus 1 over 2 ln U. What's U there? 1 minus 2v minus v squared. You have this. Make this ones the same thing. Yep. 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 Anyone left? This link. All right. So you have this. So I have this. So in essence, if I integrate this man here, see the value, see your answer there. Your answer there. So you now see how in solving one question, we've solved another full question inside. It's crazy, but that's it. In solving this one question, this one alone is a full question on its own. It's crazy, but then this is what it is. The question here would now be, if you're in the one exam hall, would you think about it this way? That's not the question. That's why I said you go and solve out there 50 examples, so your eyes will open. 50 examples. All right. This man here gives us, so what we have here, as you can see, there's minus 1 over 2 ln what's there? 1 minus 2v minus v squared. It's equal to integration over x, have what there? Ln x plus c. Okay, so we're now here, successfully integrated. What now? What next now? But v is equal to what there? Y over x. You know what that means, right? Yeah. We want to do some deep maths now. We're not done. So let's see how we can make v subject of the formula. And how do you solve that? First things first, I want to eliminate this one here. Let's say it works. Let me eliminate this one here. To eliminate this, what do? I'll simply look up, please. First things first, look up, please. Listen. I want to eliminate this one first, knowing that I'm left with what there? Ln. How do you eliminate minus 1 over 2? What do? I'm having minus 1 over 2. If I can multiply, to eliminate the minus, multiply by another minus. To cancel out 2, multiply by 2. So minus cancels minus, 2 cancels 2. I'm having it standing alone. So multiply by minus 2. Multiply by minus 2. Minus 2 here, we've seen that. Look up, please. Put minus 2 here to cancel this one out. Minus cancels minus, 2 cancels this. I'm left with ln. So I'm having ln 1 minus 2v minus v squared is equal to minus 2 into all of this ln x plus c. We're not done yet. As a power, that could still work. If you put this as a power here, this will be too complicated though. If you put this as a power, it will be too complicated, right? If I do ln, of course, this one means that the power goes up here, but that will complicate the matter a whole lot. That could work still. Yeah. Sweet. Okay. At this point, what happens here next? We say, but if you know that y, we said y is equal to vx. If we make v to be subject of the formula here, v is equal to what there? Y over x. So put v as y over x. What do you have there? We have ln into 1 minus 2v becomes 2 of what there? Y over x. Since I'm already having a round bracket, I'll change this to what there? Square bracket. All right. Minus v squared. y over x, v squared, close this, minus 2 is equal to, I want to take this off, please. Come in, please. Yes, please. Anyone works now? Anyone works? If you want to eliminate the lane first, no problem. Anyone works. This is equal to minus 2 into ln x plus c. So I have this. Yes. So I was saying, are we not supposed to like eliminate the lane first? Well, the fact is this. I want to stop here. It's not me that you guys are stressed. I will stop it here. Because see this thing that I want to do here. No, please. I'm not involved, please. Thank you. All right. Because imagine trying to make y. The mathematical process involved in trying to make y here to be subject to the formula. It's crazy. So please, it's okay. We can leave it here, no problems. So I have this. That's your answer, literally. I have said before that there are some questions under this that doesn't have an answer. So the answer will be from this, like you can't, there's some questions where at this point you cannot integrate what we see there. You don't have that the integral of this is equal to, it's crazy, but it exists. So this is just let me show you some part of it so you can see this. So it's okay to leave it at this point because trying to make y to be subject of the formula here is not today's job. So leave it there, and that is your answer. Next question, please.
Get more by joining our Differential Equations channel membership or visit www.johnnyemanuel.com/courses and get the Differential Equations Made Easy course. Both links in video description.